this slide are showing some improvements in chamber modeling. On the left-hand side, you can see something which we had previously built into SCORG. This is this Savitzky-Golay filter for filtering sealing line in case of profiles like measured profiles imported in SCORG, because in the case of measured profiles, there are usually, or if in some cases, when you import profile from 3D CAD, all these approximations that are done in a CAD or measuring errors on a measuring CMM machines can produce sealing line, which is very noisy, as you can see on the left-hand side. This Savitzky-Golay filter is used for some time in SCORG to basically correct that and produce sealing line like this one on the right-hand side. But in the previous versions, these parameters that set it up, NL and NR, so this is a number of points which is used in a filter on the left and on the right side of the rotor profile, they were global parameter. So in this version, we define them as a local parameter. So for each rotor profile, basically, you will be able to set up this value as it suits best. For good profiles, like profiles generated, using proper gearing theory, then you should set these two values, NL and NR, in profile setup to 0, because then sealing line will be good. But if you face any issues with imported profile, then you can play with these two just for this particular case, and the rest of the cases will not be. The second feature for conjugate heat transfer allows you to calculate operational clearances in the machines. On the top right diagram that you can see in this slide, yes, that one, black and orange line, and the yellow and the purple lines. So these are radial clearances on the male and the female rotors, leading and trailing radial clearance areas, so leakage areas, as a function of the angle of rotation on male and female rotor. And these are calculated in geometry module as cold clearances. So basically, they depend on what value you set up for your clearances in SCORG input. The thermodynamic selection, if you select a clearance adjustment, then you can basically calculate the change in clearances in case of cooled rotors or cooled casing, or non-cooled rotors and non-cooled casing. And it is especially important for oil-free machines. And you can see that there are different, basically, distribution of or different leakage areas happen in case of non-cooled oil-free rotors. So this example here shows non-cooled rotors and cooled casing. So basically, this is the case when you would have a jacket cooling on the casing, and rotors will be just normal rotors. And you can see the difference in the clearances. Note that the scale is different on the left-hand side. So the scale on the top diagram goes from 0 to 50 to 5 to the power of -5 square meters, whatever that is in square millimeters. But the bottom diagram goes to 3. So it is different scale. And the green line, which represents interlobe clearance, is basically the same. It hasn't changed for these two. So this is the same scale. So you can see that the change in radial clearances is significant. And the radial clearance reduce because of cooled casing and non-cooled rotors.